Hello, I'm audible. Please just confirm. Okay, okay. Let us wait for 5 minutes. For maybe another participant will join within 5 minutes. Let us wait. Hello, Kedar, I'm audible. Will you just confirm? Let us start. Maybe student will join later. Okay. Slide is visible. Please confirm once, or you can message in the chat box. Okay, okay. So, so welcome in week 6 fluid mechanics. So here we solved some problem related to your topic Langrensen and the Eulerian description, motion and deformation of fluid element, and third one is the fluid kinematics. So based on three concepts of fluid mechanics, we'll solve here some problems. So the first question is the actual travel the actual path traveled by an individual fluid particle over some period is called path line, stream tube, streamline, and the strike line. So four option is given. So okay, you are telling the option A, path line. Yes, path line is correct, but I want to discuss all three options, remaining three options. So for maybe another students. So actually path line, let me discuss here. If we select one, let us suppose I have selected one fluid body. From here, fluid is entering. So if one single individual fluid particle, let's suppose at t is equal to 0, t is equal to 1, t is equal to 2, the path of the particle is like that. Single particle, individual particle. So such type of line is known as path line. T is equal to 4 is equal, your particle is here and going outside like that. So such type of line traveled by a particular or an individual fluid particle over some period of time is known as your path line. Second, I want to discuss what is stream tube actually. Stream tube is nothing, if I draw here one tube, so basically the streams lines, or you can say the streamline tube, you can say in very general way, streamline tube. But important is what is streamline. Streamline is nothing but, if you will draw here the same in same figure I want to show you. Let us suppose water is flowing like that. At an instant of time you take a picture. Just for example, at an instant of time you take a picture, and what you will observe, you will observe some fluid particles like that. You will observe fluid particle is like that, moving, going outside. So when you will draw the line like that, because this line is an imaginary line which is joined the each and which is joined millions of your fluid particles, millions of fluid, and each at each point it will give you velocity direction. And what is your strike line? Nothing but, if you will, let us suppose you want to put here one dike system, or if you, or you can, if you will consider in gas, so you can enter here a smoke, or if it is liquid, then let's suppose some color. So how this, whatever the color particle you will here drop, that how your color particle travel in a fluid domain, so that the locus of that particle is known as your strike line. So remember please. So the next question is, if the verticity in a region of the flow is 0, the flow is incompressible, compressible, rotational. So if the verticity in a region, let us suppose if one fluid domain is here, or in this fluid domain, your at some region your verticity is 0. Verticity is 0, then such type of flow is known as by what name? Whether it is incompressible flow, compressible flow, rotational flow, irrotational flow. So please you just comment in the chat box. Okay, you are telling the option number C. Okay, so option number C, if I see, yes, if your rotation verticity is nothing but it is related to your rotation of the fluid particle. If it is 0, definitely your rotation will be, your fluid particle or such type of flow is known as irrotational. So option C is correct. But for description point of view, if I tell you, the incompressible flow is nothing but when your density of the fluid, when the density of fluid is, when the density of fluid does not change, does not change, then such type of flow is known as incompressible. Density of fluid does not change with respect to time, with respect to space also you can say, does not change. Compressible flow, just opposite, the density of the particle, density of the fluid should change. Irrotational, you know already, the verticity should be 0, that is your rotation of the fluid particle should be 0 for irrotational. Rotational, the verticity should not be 0. So rotational meanings here, your fluid particle is moving in this forward direction, but it's rotating, moving like that. Fluid particle rotating on axis and moving, rotating and moving, rotating and moving. So like that type of flow is known as rotational flow. So next question, the angular velocity of a fluid particle is 40. Angular velocity here is given. Angular velocity is given 40 radian per second. The vorticity of the fluid particle is 20 radian per second, 40 radian per second, 80 radian per second, or the 10 radian per second. So please try to give your answer. Okay, you are telling the for question number 3, your option number C is correct, right? Okay. So let me explain how it is correct. So basically your angular velocity and vorticity is how related. I will show you. Option C is correct, definitely. So your rate of rotation vector, you know already from the your basic lecture of fluid mechanics. So it is like that, half angular velocity or rate of rotation vector is nothing but half curl vector. So this thing is known as, whatever the curl part, this is known as vorticity. This is known as vorticity. So here your omega is equal to vorticity divided by 2. So definitely your vorticity will be 2 times of omega. So from here you can easily calculate, if it is given 40, it will be 80. radian per second. So very easy. So here explanation is given. Next, a car is moving at a constant absolute velocity v car is 10 kilometer per hour to the right. A high speed jet of water at an absolute velocity of jet Vz is equal to 15 kilometer per hour to a right strike the back of car, right strike the back of car. The relative velocity of water is, the relative velocity of water is for question number 4. What is your answer? So 4 options is given. Just please try to give your answer. Okay. So you are telling the option number B. Okay. So let me just explain a little bit. So in question given, a car is moving at a constant absolute velocity. V car is 10 kilometer per hour. Let us suppose the car is moving in this direction, or it is cart is given. Let us suppose like that, 10 kilometer per hour. A high speed jet of water at absolute velocity 15 kilometer per hour to the right strike the back of the car. Here it is a strike something with 15 kilometer per hour. So here is the relative velocity of water. So V relative is nothing but the difference between both velocities. 15 minus 10. It will be 5 kilometer per hour. So it is like that. But here, if I tell you, you need to calculate the force. Force applied by water on the car. So what is your answer in case of force? You can consider the area of jet. Area of jet is equal to small a. Area of jet is equal to small a. Then what is your answer for that? If you remember such type of questions we have discussed earlier. So just please calculate and just write in the chat box. Because such type of questions you can expect in the final examination and other competitive examinations also, your assignment also. So the force applied by the water jet on the car, okay, 5 kA. Oh, 5 kA means what is K here? You can write here. What is K? Vijay, you can see the question number 4 and try to give your answer. Okay, 25,000. Okay. So if you are telling, okay, let me calculate because I want to also need to calculate. So here is nothing but rho A your V relative square. So rho is nothing but 1000 A is a small a and V relative is 5 square. So 25,000 A. Yes, you are right. 25,000 will be correct. Okay, now moving ahead with the next question. So the question number 5 is, okay. Question number 5. A steady incompressible two-dimensional velocity field is given by V is equal to UV 2.0 minus 1.6 xi plus 0.9 plus 1.6 yj, where x and y coordinates are in meter and the magnitude of velocity is in meter per second. The value of x and y at the stagnation point respectively are A 0.937 meter. So x and y you need to calculate here. So options is given, you can see. So please try to give your answer, then I will explain. For question number 5, you please try to give your answer. Please read the question very carefully, then you try to solve the questions. So please try to solve within 2-3 minutes, not take much time in this question. So stagnation point means nothing but your velocity equal to 0. You just try to find out the u component, whatever the given the velocity vector. So from the velocity vector, you need to identify your u component, then your v component, then you equate both component equal to 0, then you can easily find x is equal to what and y is equal to what. That will be your correct answer. So I have given you a hint, you please try to solve at least after that. So more 2 minutes for this question, then after I will explain. Okay, let me explain. So in question is given, if you will see, let me write very in elaborative manner. So 2 minus 1.6x I equal to 0.9 plus 1.6 yz. So you know already your velocity vector is function of, here it is given uv. So definitely it will be ui plus vj. So if you will compare with this both, you will get what? U is equal to 2 minus 1.6x and V is equal to 0.9 plus 1.6y. These two things. So after that, in question is telling stagnation point means what? Stagnation point means your U is equal to and V is equal to 0. So 2 minus 1.6 x is equal to 0. You will get x is equal to what? X is equal to 2 divided by 1.6. And y is equal to what? Y is equal to nothing but 0. So again 0.9 plus 1.6y is equal to 0. So you will get y is equal to minus 0.9 divided by 1.6. When you will calculate, x is equal to 1 by 0.8 and y is equal to 0 point, or you can say the 9 by 16. When you will divide these two things, then you will get your answer very easily. That is option number C, 1.25. How? It will be 0, 8 ones are 8, then 0.25. So similarly for that also. So option C will be correct for that. Next. Next question is, okay, next question is also from kinematics, nothing much. So the local acceleration in x direction is given by u delta x plus delta u by t, del u by del t, u del u by del t, none of the above. Which option is correct for question number 6? Please try to calculate. Okay, Kedar is telling option B. Other, please, Vijay Kumar, you can also, or Rajnikant, you can also tell the answer of this question, question number 6. the local acceleration in x direction is given by u plus del u by del x plus del u by del t. B option del u by del t. C option u del u by del t. None of the above. So both please Vijay Kumar and Rajnikant, you please try to give your answer. Kedarnag is telling option B. What is your view on this question? For question number 6. Okay, Vijay Kumar is telling option B. Rajnikant is telling option A. Okay, let me just discuss. So here we are talking about the acceleration in case of fluid mechanics. So in fluid mechanics, we'll derive the acceleration thing using the Lagrangian approach, which is Ax is equal to nothing but del u by del t plus u del u by del x plus v del u by del y plus w del u by del z. So this part is known as local acceleration, and this part is known as your convective acceleration. Convective acceleration. So here only I am talking about local acceleration in x direction. So your option C, option B will be correct because we are talking, and this question is asking about only the local acceleration. So option B is correct. Now if I want to write the y direction, so definitely here v del v by del t plus u del v by del x plus v del v by del y plus w del v by del z. For next your z component, del w by what is x, basically in x direction your velocity u, in y direction your velocity is v, and in w, that is your z direction your velocity component is w. So on this with this assumption I am writing these equations. So del w by del t plus u del w by del x plus v del w by del y plus w del w by del z. So these three. So based on these equations, we have the questions. So we'll discuss maybe in the next to next question or in the last question. So we'll see later. But please just try to remember these two things. Your acceleration having two part, local acceleration and the convective acceleration. So in examination also examiner ask you the what is the value of local acceleration only, maybe one function you might be get. Your velocity is equal to velocity vector maybe 2xi plus 2yj plus 3zk. So maybe examiner asks to you, just I want answer of local acceleration all three directions. Maybe all three options will be given. So such type of, or maybe convective acceleration in three directions and all. So such type of questions might be framed in the coming in your future examinations or future assignments. So now we'll move ahead. The line of constant phi here is what is equipotentials, equipotentials, equipotential function. So our parallel streamline, are normal to streamline, are parallel to streamline. No, B option, normal to streamline. Option C, can intersect each other. Option D, none of the above. So here four options is given. You please try to give your answer in the chat box. You all people. Okay, option B, now Kedar is telling. Other student, please also you try to give your answer. Because based on your answer, I will explain like that. So equipotential line of constant equipotential functions are parallel to streamline, are normal to streamline. Okay. Other student, please also try to give your answer. Can intersect each other, none of the above. Now just I am waiting. I will wait 1 minute more. You please try to give your answer. Okay. Rajnikant is telling A option. Okay. So let me discuss a little bit. So line of constant, your equipotential function and your streamline function, what will be normal to streamline? Let me draw the, this concept will be used in fluid mechanics also if you are civil, if your background is civil engineering. So it is at 90 degree, please remember. This is 90 degree. This is 90 degree. So remember always, please. Now moving ahead on the next question. The next question is the velocity field in a flow system is given by vector v is equal to 2y plus x j plus xyzk. The acceleration of the fluid at 112 at point 112 is 4j plus 10k, 4I plus 10k, j plus k, 4I plus 10j. So please try to calculate and try to give your answer in the chat box. So please try to calculate for question number 8 your which option will be correct. Here is the velocity field is given, the acceleration of the fluid. Just whatever I was discussed previously in the previous questions, x, ax, ay, az, you need to calculate that thing. And here is asking the acceleration, so you just root out all these three. You will take sum of root all three, then you can easily identify. Or here you cannot take a root because it is asking in this format. Format is in the vector format. So here you no need to take the root. So you please have 5 minutes. So after 5 minutes, I will discuss more, or I will discuss these questions. So please try to calculate, little bit calculative. So if you will calculate, definitely you will got the answer. In case of solid mechanics, what we will do, nothing. If you want to calculate the acceleration, so velocity per unit time. But in case of fluid mechanics, the things is changed because your fluid is deformed continuously, moving and deform, both things is happening with the fluid. But in case of solid, only what, fluid is moving, deformation is very very negligible. Always we neglect in engineering perspective point of view. In some special case we can consider, but most of the case we in case of solid mechanics we neglect the deformation kind of thing when the fluid is moving, when your solid is moving. So definitely that's why we use very easy formula in case of solid mechanics, velocity per unit time. But here is things very very difficult, very very complex. So studying of such things, we have the two descriptions, Euler as well as Lagrangian. So generally in fluid mechanics, we follow the Lagrangian approach. We follow the Eulerian approach, not Lagrangian. So Rajnikant is telling option C. Okay, I'll wait for 2-3 minutes more. Okay, now I want to discuss. So here u is equal to given already. If you will compare this, your velocity component you know already, ui plus vj plus wk. So nothing but u is equal to what, 2, v is equal to what, x plus or y plus x, and w is equal to if I write V very clearly, and W is equal to X, Y and Z. So AX is equal to nothing but and AY and AZ. So here you need to calculate acceleration. So how you will? AXI plus AYJ plus AZK. So you need to calculate these three things. So AX is nothing but del U by del T plus U del U by del X plus U V del U by del Y plus W del U by del Z. So U is a constant value, so differentiation will be 0. So your Ux will be 0. Now come on the Uy point. Okay. So y, if we calculate del U by del T, del V by del T plus U del V by del X plus V del V by del Y plus W del V by del Z. So here your T term will be 0 because your V direction velocity or V is equal to Y plus X only, not having the T functions. So U is equal to 2 and del V by del X. So yes, definitely X function is there. So it will be 1. So if I write here del V by del X, yes, definitely this will be 0 like that. Del V by del X or here Y plus X. Next V. V is what? Y plus X and del Vy del Y. So V is what? Y plus X. Now W component, W is X, Y, Z and del V by del Z. V is X plus Y divided by del Z. So how you will calculate these things not having the Z function? So this will be 0. Here this will give you 2 and this will be 0 and this will be 1. So 1. So this will give you 2. So 0 plus 2 plus Y plus X. When you will calculate with this, so this will give you 1 and this will be 0. So here X plus Y only this component will give you and this component will again 0. So when you will put 1, 1, 2, X is equal to 1, Y is equal to 1. So here 0 plus 2 plus here 1, 1, 2 equal to 0. So again it is 4. So it is 4, right? So AX is equal to 0, AY is equal to 4. So 0Y plus 4Z. So okay, only here if you will see your J component with 4 only one option is given, A option. So it might be one A option will be correct. Yes, A option will correct. So if for some student, let me calculate Z component also. So AZ is equal to nothing but del W by del T plus U del W by del X plus V del W by del Y plus W del W by del Z. So definitely again your W component not having the T, so this will again 0 plus U. U is what? U is 2 and W component having X. So YZ again it will remain YZ plus it will remain YZ. Only if it is differentiation with respect to S, definitely Y and Z will be remains. Now V is what? X plus Y, and if you will calculate your W with respect to Y, yes, again it will remain your X and Z. Now W X Y Z, when you will calculate with respect to what? Z, again remain X and Y. So when you will put 1, 1, 2, that is X is equal to 1, Y is equal to 1, W is equal to 2, you will get what? First term will be give you 0, second term 2YZ. 2YZ means 1 and 2, that is it will be 4 plus 1, 1, 2, again 1 and 2, 2 to 4 plus here X and Y and Z, it will be 2 and Y X 1 1, so it will be 2, so it is coming 10. So here you can see your, if I write here AZ is coming 10, so you can write 10K. So easily your X you can write, definitely 0 means nothing here, so 4J plus 10K, so your A option will correct for that. So here is lots of calculation, but by your there is no need to calculate the Z component if your question is objective type, because you can whatever I have tell earlier just few minutes back, so like that you can calculate, like that you can choose the answer. Next question, question number 9. Okay, here is a solution part. Question number 9 is whether, verify, here you need to verify whether the following function is valid potential function or not. So function is phi y cube, let me write little bit bigger, y cube plus y cube minus y cube minus 3x square y. So you please try to calculate this function is valid or not, valid potential function or not. After that questions I will take little bit, I will take the 5-minute break. So please try to solve these questions. We have again 5 minutes for that. So for validation of your potential function, which equation should be satisfied? If you know, you can easily calculate. Otherwise, after 2 minutes, I will give you hint how you will calculate. Then you calculate. So here please you can apply your Laplace equation which involve the equipotential functions. So just little bit hint I have given you. After that you can try please. If you will apply the Laplace equation, if your Laplace equation is satisfied, that means equal to 0, then you can easily we can say this potential function is valid. If not satisfying, that is not equal to come 0, then definitely not. After that please you try to calculate. Okay, you are telling the option A, that is this is the potential function, valid potential function. Kedar is telling yes. Okay, other student please, Rajnikant and the Manishwa. Rajnikant is also telling A. Okay, so let me just check. So if you people are telling A, definitely answer will be A, but how you will calculate? So just I want to show you. Or let me just write, because when I will write it will be del x square plus del square phi by del y square is equal to 0. So your here what is del phi by del x is equal to nothing but your minus 6x square 6xy, and del phi by del y is equal to nothing but 3y square. Again, when you will take the double differentiation, what will happen? Minus 6y, and this will give you, when you will take the double differentiation, 6y. When you will add these two things, it will be 0, so definitely it is satisfying. Now moving ahead with the next question. Okay, next question I will show you, then after I will go for 5-minute break. You can also take 5-minute break. So question number 10. So question number 10, what is telling? Let me read. The flow field of a fluid is given by V vector. Let me write here very clearly. Y square I minus xyz plus 2k. The value of z component of angular velocity. The value of z component of angular velocity at point 0, -1, 1 is. So you need to please calculate angular velocity component in z direction. Here all three direction you can calculate, but in this question particularly you need to calculate the z direction angular velocity. Here I will show you all three component, but you so within 2-3 minutes please try to finish. Okay, Rajnikant is telling option D. Good. So other student, please also you try to give your answer. Okay, let me show you just. So actually your vorticity, if I write you, if I represent with omega, it will be the vorticity in x direction. that is angular velocity in x direction, angular velocity in y direction, and angular velocity in z direction. So we have three components, but here in question asking only the IJK, here asking only z component. So here your with this, if I compare, u is equal to y square, v is equal to minus xy, z is equal to 2. So what is this? This is nothing but earlier we have discussed, that is half what? If I tell you this omega is equal to nothing but half del curl v vector, right? So it means half I j k del by del x, del by del x, del by del y, del by del z. Here u v w. This represent you wx. This column, if I calculate, this is wy, this is wz. So how you will calculate your wx component? If I say, or wz, let me. So wz is nothing but this into this. So del v by del u, del v by del x minus del u by del y, half. Here half will be. So what you will write? Del u by del v by del x minus del u by del y. So similarly, you can calculate for your wy and wz both. So, but here we need to calculate what? Wz. So half, when you will differentiate with respect to x, your y, that is v component, so it will be minus y, minus when you will differentiate with respect to your u with respect to y, so you will get 2y. So this will be minus 3y divided by 2. So your y value is given here, x is equal to 0, y is equal to minus 1, z is equal to 1. So when you will put minus 1, it will be again 3 by 2 in positive. So 1.5. Your C option will be correct for this question. Remember please, C option will be correct. So now we'll move ahead on the next question. Okay. Now we'll move ahead on the next question. Next question is, okay, if someone want to calculate your wy, then wy, how we will calculate? Wy is nothing but j component. So how? Wx, that is your w minus wx minus this one del u by del z. But here one thing is remain. You remember please, when you will open this, then here we have the positive term, but when you will actually this open this your matrix, this differentiation, or that is this determinant, then the minus will come here if you will take like that. For incorporating this, you will multiply with this, then your del u by del z will come forward, and del w by del x back. So a little bit change here. So this is your wy, that is half. Here half will be there. Similarly for wz you can calculate, or wx, because we have, so wx very easy. For wx, your del w by del y minus del vy del z. So similarly you can calculate all these things. Now with moving ahead, next question. Next question is, the Euler equation can be integrated if, the Euler equation can be integrated if the fluid is compressible, the velocity potential function exists, and fluid is incompressible, flow is irrotational, continuity equation is satisfied. The four option is given. The Euler equation can be integrated if, which option is correct? The velocity component is, the fluid is compressible, the velocity potential function exists, and the fluid is incompressible. The flow is irrotational, the continuity equation is satisfied. Question number 11. Okay. So you can think again. You have 1 minute more, 2 minute. Okay. So let me just show you answer. So your Euler equation can be integrated if your velocity potential function exists. Actually all options, your C option will correct also, that is irrotational is given, not correct, but continuous equation is satisfied, but you have to choose the best appropriate answer. So your B option here will be correct. Your Euler equation can be integrated if velocity potential function exists, that is it should be valid, and the fluid is incompressible. Next question, the stream function along a streamline. The stream function along a streamline, 0, increase, decrease, or constant. So please try to calculate. Try to actually think on that. Here is only the theoretical questions, not the calculative. So stream function along a streamline, whether 0, increase, decrease, constant. 2-3 minutes. Within 2-3 minutes, please try to give your answer. Okay, Rajnikant is telling D. Kedar is also telling D. Okay, I'll wait 1 minute. Okay, so Manishwar is also telling. Okay, good. So definitely it will be constant. Your stream function along a streamline, it will be constant. So good. Now we'll move ahead on the next question. Next question is the equation of a streamline passing through 1, 1 for a velocity component u is equal to y square and v is equal to 6x. So you need to calculate the equation of streamline. Equation of streamline passing through 1 comma 1 means x is equal to 1 and y is equal to 1. So please try to calculate your equation of streamline. So please try to calculate very quickly, then I will discuss the correct procedure and answer. I will show you. Okay, let me show you. So here you need to calculate the equation of a streamline. So already you know del u by x plus equal to del v by u. This is wrong. Del x by u is equal to del y by v. So this equation you know already. So now you can calculate very easily. Del x by y square equal to del y by 6x. So dx 6x plus equal to dy y square. Integrate both sides. So 6x square by 2 is equal to, here is y square. So y cube by 3 plus c at 1 comma 1. C is equal to what? Here if you will put 1, 3, and here if you will put 1, 1 by 3. So 3 minus 1 by 3, you will get what? 8 by 3. So now you can put 6x square by 2 minus y cube by 3 plus equal to 8 by 3. So if you will multiply by 3, what you will get? You will get here 9x square minus y cube equal to 8. 9x square minus y cube equal to 8. So I think B option should be correct. Let me just check. Yes, your option B will be correct for that. So how you will proceed with that? Such type of question you just I have explained. Now question number 14. For a stream function phi is equal to x square minus y square. Find the flow between the 2 point 2 comma 0 and 0 comma minus 1. So please try to calculate for question number 14. For question number 14, so the find the flow between 2 points 0 2 comma 0 and 0 comma minus 1. It is very easy, but I will give you 5 minutes. Within 5 minutes, please try to. Okay, let me discuss. So here is nothing. You need to calculate the flow between 2 points. So what is phi 1 minus phi 2? So this is the formula. So you can write here. What is your phi 1? Phi 1 is this at that point. So phi 1 is equal to what? X equal to 2. So here 4, if you will put here, phi is equal to 2 square minus 0 square. So you will get what? 4. Phi 1. And here if you will put phi 2, phi 2 is given 0 minus 1. So 0 square minus 1 square. So you will get plus 1. This is plus 1. Again this is minus. So minus 1. So minus 1. You will get what? 3. So your flow is 3 unit. Very easy, but remember please, such type of questions a little bit, oh how it is 5, here is minus already given. So if it is minus 1, answer 5 will I think wrong, because yes, oh how it is 5, here it will come 4, yes minus, okay minus in between, okay got it. So this will give you minus 1, and in between here minus 1 is there, because minus this is 4, this is minus 1, and this is minus minus plus, so it will give you 5 unit. So option C will correct. Now moving ahead with the next question. Next question is, the velocity potential function phi is given a to the power x plus y. The flow is irrotational, rotational, impossible, and cannot exist, none of the above. If phi is equal to e to the power x plus y. So which option is correct for question number 15? So please try to calculate within 5 minutes, 5 minutes. Question number 15. E to the power x plus y. So whether it is rotational, rotational, impossible, cannot exist, and none of them. Okay. So let me discuss. So phi is given like that. So when you will calculate your del phi by del x, what will come? A to the power x plus y into 1 plus del y by del x. When you will calculate del phi by del y, it will come e to the power x plus y 1 plus, or here you can write the del x by del y 1. When we will calculate the square root of this, when we will go for a square, then when after adding, this will never going to be 0, because here is del y by del x by del y, so this never going to be 0, so impossible. So in it cannot exist. Okay, so this is the whole things. Next question, this is from gate 2023, I think. The question is, the pressure in a pipe at point X is to be measured by an open manometer as shown in figure. Open manometer is given. Here is P atmosphere. Fluid A is oil. Fluid A is oil with a specific gravity 0.8. Fluid B is mercury with a specific gravity 13.6. The absolute pressure at X. The P absolute you need to calculate in kilonewton per meter square. Assume density of water is 1000 kg per meter cube and acceleration due to gravity 9.81 and atmospheric pressure is 1.3 kilonewton per meter square. So here you need to calculate the absolute pressure. So please try to calculate. This is from your very beginning classes. I think this is from your first class. So please try to calculate. So you have 3-4 minutes or 5 minutes you can take, because this is calculative. Then after I will show you answer. I have more questions. So might be today we will not complete all questions. So in some day I will discuss. Density of water is 1000 kg per meter cube. So whatever you will get answered, please you can write in the chat box. Here options is not given. This is a numerical type questions. Okay, let me calculate. So here P absolute is nothing but, you know already, I have discussed earlier also. P absolute is P atmospheric plus P gas. Right. So what is your P gas? At X, we are talking about X. So nothing but you will move from here to here in this direction. Rho GH. So H is how much? 0.75. So rho is, this is oil with a specific gravity 0.8. So 0.8 into 1000. Why 1000? Because it converting from a specific gravity to density of liquid into G 9.81 into depth 0.75. Then again for this depth you will move up to that. Then again you will come down with this depth. So this both component will cancel out. This both whatever you will write here plus these things and minus these things, this will be cancel out. Now we'll move ahead with this. Whatever you will write this and whatever you will write this again go up. So it will be cancel out each other. So remaining part only this. So rho for what? This is mercury. So 113.6 into 1000 rho Z 9.81 into H how much? 0.25. So this is gas. Okay. So whatever it will come, you need to just calculate, or if I calculate very easy, and you need in kilonewton. So you need to divide this with 1000, this component also with 1000. So you will get what? 0. Again 0.8 into 9.81 into 0.75 plus 13.6 gune 9.81 multiplied by 0.25. So when you will multiply, you will get what? Let me just calculate. So 0.8 into 9.81 into 0.75. So it will become around 5.886 plus 13.6 into 9.81 into 0.25. So it will come 33.354. So when you will add plus 5.886, so you will get 39.24 kilonewton. But you need to calculate P absolute. So your gas, that is 39.24 plus absolute value. Absolute value is how much? 101.3. So this is in kilonewton per meter square. So when we will add plus 101.3, so you will get 140, that is 140.54 kilonewton per meter square. So it is very easy. So such type of question you can calculate like that. So one thing I want to discuss here. Okay, so battery is low. Let me just plug in the charge. Okay. So P absolute, sometimes the question will come. So here you can easily calculate what is your P gauge. P absolute minus P atmospheric. Sometimes vacuum pressure. So what is, let me ask to you. So what is vacuum pressure? Please anyone can write in the chat box, because I have earlier discussed lot. P vacuum. So whether it is related with your absolute or atmospheric or gauge, what? Just I want to know from your side, then I will write. Within 1 minute, please try to write. Vacuum pressure is less than atmospheric. Okay, good. Okay. So gauge pressure here, it will be your greater than your, definitely for atmospheric pressure, but your pressure will be less than, when your pressure will less than atmospheric pressure, definitely your pressure will be vacuum. So vacuum is a negative pressure than the atmospheric or the barometric pressure. Remember please always. Okay, good. So vacuum pressure is nothing but your, whatever the pressure you have measured at a particular, like P atmospheric minus whatever you will measure the pressure here. Let's suppose P. So this will give you vacuum pressure. So that is, if atmospheric pressure is here, you are measuring from here. If atmospheric pressure here, so if your pressure is lies here, then it is in vacuum condition. Remember please. If you will put the pressure values and this coordinate. So this is the concept behind your vacuum pressure, gauge pressure, and the absolute pressure. So with that, today I will close the discuss. So we'll meet again in the next class, I think on next Monday. Yes, definitely, definitely, yes, correct, correct. So the good information. So okay, so now we'll okay, now I will close the session today. We'll meet again in the next class. So thank you, bye bye for today. Thank you all. Now you can. Okay, good night. Bye bye.